Okay, so in this video, let's understand how Bag of Words works. So Bag of Words is basically a technique to vectorize your data from English to numbers, right? So that the model, machine learning or deep learning model can understand it. So how does Bag of Words work? Is Bag of Words is basically one-hot encoding. How it works is, first I take this entire corpus. Let's assume that the corpus has only three reviews, but in reality the corpus will have over 1 million reviews. It can exceed 1 million reviews, but for the sake of simplicity and explanation, I'll just use these three reviews right now. And once you have cleaned your data and deduplicated it, removed all the stop words and everything, what you would do is you basically create a corpus or a dictionary of all the words that are present in your data set. So the words would be the noodles are very not cheap, and whatever, this list would keep going on and on. So this is a dictionary of all the words that are present in my corpus. So how do I vectorize it? Is that I create a vector. Let's create this vector, and each dimension in the vector will correspond to each word in my dictionary. So the first dimension would be the, a, and whatever, and then noodles, okay, and something like cheap, and it goes on. Like this vector will be huge. If your corpus is huge, this vector will be very, very big. The dimensionality of this vector, the total number of dimensions in this vector, will be equal to the total number of uh, unique words that you have in your dictionary. So if I have, let's say, 200,000 words, unique words in my dictionary or in my corpus, then this vector will have a dimensionality of 200,000 features. And for each review, R1, R2, I'll have each one of these vectors, okay, right? So in the review R1, wherever I have the, I would give it a value of 1. In the review R1, I don't have A, right? A and the. I don't have A, so I'll give it a value 0. I don't have an, I'll give it a value 0. So I do the same thing, and I have noodles there. I give it a value of 1. I have cheap here. I give it a value of 1. Whatever words I don't have, it'll get a value of 0. If a word appears twice, then I would just, instead of 1, I would give it 2. If the appears thrice in a review, I would give it a value 3. Okay. So in this case, for explaining, I've used the word the, but once you do something like stop word removal, the would go away. You won't have the in your vector, feature vector, right? So similarly, I would do this for all the reviews, R1, R2, R3, all the way till the end. And whatever I get, I would just, whatever, how many ever words there are in that particular review, I would just keep adding the count to that particular feature. And then to analyze it, you can use something like a dimensionality, no, sorry, I'm sorry, like a distance technique, like Euclidean distance. So I can, to see how close they are or how similar they are, I can use something like cosine distance or Euclidean distance, right? Because the smaller the difference between these, the closer they are in the feature space. And the closer they are in the feature space, the the more similar the reviews are. So that's how you would go about creating bag of words. Okay. Now this is called normal bag of words. You can also have something called binary bag of words. Instead of in binary, what you do is you just give it a value of 1 or 0. Doesn't matter how many times the appears in your data set or your particular review. If it appears 10 times, it doesn't matter. In binary bag of words, you would give it just 1. If it appears, it gets a value 1. If it doesn't appear, it gets a value 0. In normal bag of words, if the appears 10 times, you would give the value 10 over here. But in the normal bag of words, sorry, in the binary bag of words, you would just give a value 1. Okay. So yeah. That's what bag of words is. But now if you notice something, there's a problem with bag of words, right? Once I've done something like stop word removal, the thing is very is also a stop word. And if you do something like stop word removal from NLTK's library, the, are, very, and they all go out. So ultimately, if you do stop word removal for review R1 and R2, you would have exactly the same thing. Review R1 would be noodles, tasty, cheap. Review R2 would be noodles, tasty, cheap. But we know from reading these reviews that they are entirely different. They mean very different things. The first one says that they are tasty, which is the positive review, and the second one says that they're not tasty, which is the negative review. So that's not correct, right? So this is one problem with bag of words, that it doesn't take the semantic relationship of reviews into consideration. Once you've removed all the stop words, these reviews just become equal, the same. So that's a problem with bag of words. To overcome this, there are some techniques. You have something called unigrams, bigrams, and trigrams. Okay, unigrams, bigrams, and trigrams. So what unigrams is that if you take one word as a feature for each one of your reviews. So here I've taken the, a, an. Okay, if I take one word as my feature, then then it's called unigrams. Okay, so how does bigrams look? In bigrams, I take two words one after the other as a single feature. So if I take review one and I try to model it using bigrams, the review one would be the noodles. Okay, because review one is the noodles are very tasty and cheap. Okay, this would be one feature, right? Noodles would be a second feature. Are very would be a third feature. You see what I'm doing here? I'm just taking two words together. The noodles are very, very tasty, tasty and cheap. So these would be are very, very tasty, so on and so forth. Okay, this is how I would featureize my vector or my review using bigrams. Okay, so every time I get something like the noodles are very, very tasty, I would put a 1 or a 0 here. Okay. Similarly, trigrams are the same. In trigrams, what you do is you would have something like the noodles are. Okay, this would be one feature. Noodles are very tasty. Are very. This would be the second feature. So on and so forth. I hope you get the idea. So you can extend this idea to bigrams, trigrams, 4 grams, 5 grams, whatever. But this helps you overcome the problem of semantic relationships after cleaning the data to some extent, but it's still not perfect. It comes with its own problems. When you have bigrams and trigrams, you would have a very, very large feature space. I mean, like I said, if you have a dictionary of 200,000 words, if you use unigrams, you would have 200,000 features, which is very big. 200,000 features into 1 million data rows, right? That's like what? That's 200 million. So bigrams, what bigrams will do, if you use bigrams, your feature space will be much larger than 200,000. And trigrams will be even larger than bigrams, okay? Because you have a lot of combinations of words that can come one after the other. So this is one problem with bigrams and trigrams, that, the feature space increases exponentially, which can lead to your data set becoming very big and very heavy, very memory heavy, and it can also lead to computation problems because it'll be slower to compute such a large data set. So this is what you have to remember in bag of words. It does not consider the semantic relationship of words. It only considers how many times the word appears in a particular review, and it vectorizes it. We will look later how to overcome this problem of semantic relationships in words when we learn word2vec. But this is how bag of words works. This is one of the featureization or vectorization techniques for your natural language processing problems.